This is Radio TV Phono Nut, and here we have what appears to be a book entitled The World of Music. Looks pretty good. It's a little bit worn, so somebody must have enjoyed it. So let's open it up and see what this is all about. Oh my goodness, it's not a book at all. It's actually a Crosley radio from probably about 1955, late 55, early 56. Somewhere along those lines. So yeah, we open it up to reveal an AM portable radio. We have our tuning knob here, and an off-on volume knob here, and the retainer screw that holds it all together. So let's loosen it up and see what we have inside. Alright, here's the inside. I see a nice long ferrite rod antenna. I see 3 bumblebee capacitors. I see a couple of blue Raytheon transistors here, and I see buried down in there about 3 sub-miniature tubes. So let's take a look at the schematic and see what we have here. Here's the schematic out of the manual of most often needed 1956 radio diagrams. We have our oscillator and mixer tube, our IF amplifier tube, our detector and first audio tube, which is transformer coupled to a push-pull germanium transistorized audio output stage, which is then transformer coupled to a speaker. Now, this thing operates off of 2 batteries, a 45-volt battery for the B+, and a 4.5 volt mercury cell for the filaments, although the actual filament voltage is stated as 3.25 volts, I believe. Now, just to give you a little background, the Crosley sold out his radio corporation to Avco Industries in 1945, and they kept the Crosley division active until 1956, at which time the Crosley Consumer Electronics division was no longer profitable, so Avco shut it down at that point. So this radio that we're about to dive into was one of the last, if not the last, radios that was made under the Crosley name. I don't know of any fully transistorized Crosley radio, because I believe Avco shut them down before they got that far. And in another video way down the road, I have a little 17-inch Crosley TV from about 1956 that we hope to get that going one day. Now, to my knowledge, when Crosley, there I go again, when Avco shut Crosley down in 56, the name didn't appear on any kind of consumer electronics again until I believe it was North American Philips paid for the rights to use the brand name on some of their televisions, and that was in the mid to late 1980s. And then by the early 90s, the sleazeball group that markets all of the modern day replica record player and radio garbage bought the rights to use the Crosley name, and we know what kind of sleazy trash that is. In fact, I'm sure Powell Crosley Jr. would be rolling over in his grave if he knew that his name was being slapped on 10th-rate Chinese garbage. And as far as what I plan on doing to this radio, I don't have the correct batteries to power this, but I do have a power supply that I can get the correct voltages from. That'll have to do for now. And I'm really going to do as little of this radio as possible. I'm not going to go hog wild with it. You know, this is more or less a novelty, and it's not something that I'm going to use all the time. And I'm not going to replace any of these bumblebee capacitors unless I just have to, because after all, bumblebee lives matter, right? And what I may do, if one of them absolutely has to be replaced, I might attempt to cut it open and install a modern capacitor inside, because this is one of those oddball radios that you don't see very often, and I want to keep it looking as original as possible. And as far as other radios that used sub-miniature tubes and a mix of sub-miniature tubes and transistors, I know Emerson had one, Automatic Radio had one, Sears Silvertone had one, but of course that was made by somebody else, not sure who. I'm pretty sure Motorola also had one, and those are the ones I know about. Now, in the mid-60s, General Electric had a series of hybrid AM/FM table radios. Some of them had a clock. Those used regular miniature tubes and were AC operated only, and used a transistorized FM front end, and those radios are still pretty common, unfortunately. They're also a pain in the butt to work on. Good radios when you get them working right, but getting them working right can be a royal pain. Okay, I've blabbered on enough. Let's get this down to the bench and put some juice to this and see where we are. There was also a version of this radio that had a micro switch that shut the set off when the book cover was closed, but this is another one that has a standard off-on volume control. I'm not sure which came first or whether they were made simultaneously. And these also came in several different book titles and colors. No, I'm not going to attempt to collect every one that was ever made. That would probably cost me some dough. One's enough. Alright, I had the filament supply set for 3.4 via these resistors because my pot fell apart and I had to come up with a quick fix. So 3.4 on the filament, 45 on the plug. Alright, we're plugged in, connected. Let's turn it on and find out together what it's going to do. It appears that it's going to do absolutely nothing. Alright, now let's try it. Wasn't making very good connection. Alright, I'm hearing a buzz in the speaker. That's good. We touch the center of the volume control. That's very promising. The audio amplifier stage is working. Alright, volume wide open, buzz in the speaker, tuning across the dial now. And we're getting absolutely, hold it.
Only way to look up, well, means different than everybody else. You don't didn't agree with sitting.
Alright, we're getting something. That's a good sign.
But we fought for your right to do something we don't agree with.
Is the reason this happened and not the knee on the neck? We'll determine that.
Okay, we know the audio section is nice and stout because we got a nice loud buzz when we touch the center terminal of the volume control, so that tells us we need to look in the front end stages. Alright, I'm looking at the schematic for possible things to look at with this radio, and I see 3 electrolytic capacitors so far. One is this 8 microfarad bypass cap on the B+ line. And we know from working on previous battery sets that cap can open up and cause no reception at all, oscillation, any number of problems. Then we have this 10 microfarad cap here that looks to be the cathode bypass cap on both the IF amplifier tube and the mixer tube. And if that cap opened up, that could definitely cause poor sensitivity. Now on these particular tubes, these are directly heated tubes, which means the filament and cathode are all one and the same. And then we have this other cap down here, this 50 microfarad, that if we trace it back through here, It's the emitter bypass cap for the 2 output transistors. Now, I'm sure that cap is probably bad, but I don't think that's causing our problem, because as you recall, we got a pretty good buzz at the speaker when I touched the center of the volume control. So let me locate these capacitors here in question and see what the condition of them happens to be. Alright, we have our plus connection of the electrolytic capacitor soldered to the appropriate place, and let's touch our negative to ground and see if the volume goes up any. Okay, no notable improvement. So let's move on to another one. Okay, we have our B plus bypass cap shunted. Let's apply power and see if any change is noted. None. And last, let's jump out the emitter bypass capacitor, which connects to this yellow wire here. No change whatsoever.
There's a covenant with Noah. There's a covenant with Abraham. There's a covenant with Israel.
Alright, I found part of the problem. We were not making good connection on these battery contacts. And we're now tuned to 1390, which is very overly modulated.
These covenants are not only dealt with at why Colin Kaepernick national football, or doesn't play in the National Football League again, or at least gets that.
It's wide open on 1010 WMOX.
Marcus Mariota right now, for example, is going to make $7.5
million. Could be better. We might need to jump the caps again, since we have a better power supply connection established now. And that speaker obviously has a torn cone, so we're going to have to address that.
Because when you shop,
alright, I'm jumping out the cathode bypass cap for the converter and IF tube. With the cap, I have more static and noise. Without the cap,
and your personal information. Thankfully, there's Norton 360 with LifeLock.
No noise, so that tells us something's going on there. Well, I know what needs to be done to this. Some caps need to be changed, but I'm in a dilemma here as to whether I want to proceed with this or not. As you can tell, this is a very, very, very packed up chassis, and in order for me to get to some of the caps that need to be replaced, this ferrite loop stick antenna needs to be removed. Then we need to remove this ground shield, and it's just very, very fragile all the way around, so I just don't know here. And like I said, this is not something I'm going to be using. This is more of a historical piece than one that's actually going to be put to use. Okay, I have the loop stick dismounted from the chassis, at least physically, and if you work on one of these, be careful, because there's a couple of little standoffs that will fall off and get lost. You don't want to lose those. Now, let's make note of where the loop stick electrically connects. This stub right here, and this stub right here. I'm doing this mainly for my benefit, so in case I forget where this goes. But I'd feel more comfortable getting this out of the way so I can more easily work on this without possibly breaking the wires off. Okay, in order to gain access to this electrolytic cap, I had to remove the bumblebee that's in front of it, and while we have it out, we'll check it for leakage. So as far as I can tell, there's a total of 5 bumblebees in this set. And you see one of the sub-miniature tubes clearly. This radio most likely was really not meant to be serviced. And I'm sure with the components that was in here, it probably lasted, 10, 15, 20 years, and the manufacturer probably figured that You know, if they got that much time out of it, then they probably weren't going to bother having it fixed, so they really weren't too worried about making this very servicer friendly. Alright, this bumblebee is measuring about 0.2. Let's check it for leakage. Yeah, even on the lowest voltage scale, which is 20 volts, which I can tell you that's bull crap, probably more like 100 volts, but even at that, this capacitor is very leaky and it probably needs to be replaced. Alright, on the 20 volt range on the leakage tester, it actually puts out about 85 volts. And this cap, as you saw, was leaky as all get out. It's measuring 0.14 microfarad on the little meter here. Okay, this capacitor looks to be a 0.1 microfarad. The schematic's kind of smudgy. The schematic says either 0.05, 0.06, or 0.08. I can't really tell. It's not that crucial. And I know I said I was going to try to crack these open and stuff a new capacitor inside of them, but I don't think I have any 0.1s that we can physically stuff in here, so I'm probably just going to replace it with a regular cap, and I'll keep what I take out and put in a little plastic bag and keep inside the radio. But before we replace this, we've got to replace that electrolytic, or at least pull it out and check it. And on that note, if any one of those electrolytics were extremely leaky or shorted, which usually they just dry up and open up, but one could be leaky or shorted. If that's the case, my previous test of bridging a good capacitor across it might not work so well. And here's electrolytic number 1. It's our B+ bypass cap. It's supposed to be 8 microfarad. And it's doing all kinds of weird things on the cap meter. It's just going all over the place, from 6 to 7 to 8. Went down to 1 at some point. So yeah, that capacitor's finished. Good old Nashville capacitor. Those are notorious for going bad. Okay, to make this a little easier, I managed to get the board out just enough where I could gain access to the other side, so that helps a little bit. I'm now testing a 0.022 microfarad, and it's even leakier than the first one we tested. Well, this 50 microfarad emitter bypass capacitor for the output transistors is weak. It's supposed to be 50. It's reading 22. Okay, here we are recapped. 5 bumblebees, 2 electrolytics. The schematic shows 3 electrolytics, but I'm only finding 2 on the board, but that's nothing unusual. Now, the next thing is to get all this back together and pray that it still works at least as good as it did before we took it apart. Well, I forgot we have to address the speaker, so I guess before I put it all back together, I'm going to have to take that out and repair the speaker. Here's another 0.1 that I don't think I've showed you the leakage on, just getting barely a little bit of eye opening, which is not a good sign. Yep, very leaky. I swear these bumblebees that were supposed to be such a big improvement over the old wax-covered paper capacitors of the 30s and 40s often test worse than the old wax-covered paper capacitors. A 0047 is just giving us only a slight hint of eye activity. I bet the light stays on all the time with it. Well, no, it's blinking, but nevertheless, it's still very leaky. Alright, let's ESR test these Nashville capacitors, these electrolytics. The 50 microfarad at 6 volts is giving me a very high, not even moving the meter. And here's the 8 microfarad that was going all wonky on my capacitance meter. It appears to have an intermittent. Of course, now it's not going to do it on camera, but Oh yeah. And it's not my alligator clip lead either. It's definitely has an intermittent condition here. So yeah, they're all bad. Alright, we have it all back together, and I really can't say that this is working all that great. The speaker has certainly seen better days. The only station that comes in with any kind of volume is this overmodulated gospel station. And to be honest with you, I'm not really interested in tearing this rat bed back apart and trying to figure out what's wrong with it. Like I said before, this is not something I'm going to use. This is more of a novelty than anything. I just wanted to hear it play. And I've heard it play, and it's probably fixing to go back in the case and be put on the shelf, never to be worried with again. Alright, I'm connected to the signal generator and tuned to 455 KC, and I can tell you the alignment is way off. This is coming in peaked at about 480 KC, so either somebody has been diddling with these IF transformers or the internal capacitors have changed the value and thrown the alignment off. Alright, this one, that one seems to be pretty well on. That one's not on. And let's turn the signal generator down and do the bottom cores. Okay, aligning the IFs with the signal generator to 455 actually made the reception worse, so I just did it by ear, and I pretty much had to bottom out the slugs of the IF transformers to get the best performance, so that tells me that the capacitors inside of the IF transformers have drifted in value, and that's a common problem with these types, in addition to silver mica disease. And these are actually smaller IF transformers than what's in your typical AA5 radio from the 50s, so I'm not going to worry about this. I've got the volume on turned way down now. It does get louder, and that's wide open, and that's about as loud as I would.
We are just talking about the work. So that's a little different. You know, when you have someone that's staying home all the time, that person may get a little irritated a little more because
loving somebody and sharing a space with somebody are two different things.
Two different things. And
yeah, this is not going to bring in any distant stations. Okay, there it is, and I've about done all I'm going to do to this. Alright, here we are back together and ready to put on the shelf where it will probably sit from now on. And even though I wanted to hear this radio play, and I achieved that function, I actually got it to play to about as good a level of performance as it was ever capable of. This is one of those radios that if you find one, it's probably better left alone as far as a collectability standpoint, as in leaving the old bumblebee capacitors and all that in place. Now, I kept all the capacitors out of this one, and at a later date, if I decide to crack them open and put some yellow axial lead caps in there, I can do that, but I'm really not not really worried about that. As far as the rarity of this radio, it does not appear to be too rare, because I just looked at completed listings on eBay, and over the past 2 or 3 months, there was 8 or 10 of them that sold, and there's actually one up for sale right now for some ludicrous price, like $300, something like that, which is just totally insane. And the completed listing prices that I saw was anywhere from $15 up to over $100. It's like anything else on eBay. It all depends on condition, how many people see it, and how badly somebody wants it. And when it really gets interesting is how badly do 2 people want it. That's when the magic starts happening. Now, when this radio was made, tube-type portables were already on their way out. In fact, even when this was made, there were already all transistor portables making their way onto the scene, and the advantage to those are that they don't require the expensive batteries that a tube portable requires, and they'll run a lot longer on a battery than a tube portable will run. Now, my mentor, that was a retired TV radio repairman from back in the 50s, 60s, and early 70s, I think he gave it up when the solid-state TV started coming into play and his health was going downhill, and he didn't want to have to buy new test equipment and relearn things, so he just gave it up. But had somebody brought this radio in his repair shop in 1965 to get it fixed, he would have most likely told them that, you know, you just don't even need to worry about fixing that, because for what the batteries will cost to fix it, to operate it, you could buy a little transistor radio, and by the time you pay me to fix it, you could have bought a little transistor radio. And right here is a little Magnavox 8 transistor radio that I believe was actually made by NEC, and it's about 10 years newer than this Crosley radio, and is a much better performer. So, from a usability standpoint, you know, this would be the way to go, the little Magnavox. But as far as a collectability standpoint and a historical standpoint, this little Crosley is very interesting, and in the fact that it was one of the last Crosley radios made, and that it's hybrid. It uses a mix of tubes and transistors, and it's also an early piece of electronics where you can see where they were really starting to miniaturize the circuitry. So, you know, there's a lot of cool points about this, but as far as usability, you probably just want to stick to something like this Magnavox. This Magnavox needs some work, but
and I want to remind you that if you have a computer problem, the real...
There's a chicken and egg in this situation, right? At what time do you think, okay...
Yeah, as you can tell, this Magnavox works really well. Now, would I pick up another one of these Crosleys, especially one in another series? If I found it for a reasonable price, yes, I would. But that one I probably would not repair. I would just leave it all original and just put it up on the shelf. Alright, there you go. I'm about done with this. Hope you got something out of it, and more to come later.